All right, it's about that time again. We have Euclidean Algo. Hair's all messed up. We're gonna do it in C. So open up VS Code, share. All right. Oh, that's right. We're still trying to figure out the whole like red number thing. That was a little bit annoying. This would be easier, way easier in Python, but I want to control everything, so we're gonna do it all in C. Um, did I write this with the L? Oh, what? How it should work if we compile. GCC. Everything's not really red. It's based on time. So for example, like if I that's so annoying. It's so annoying. Um, how to get random numbers. See accurately. This is really annoying. This is really annoying because the random numbers, these aren't random though. That's the problem that we're getting is that, oh my gosh, this is so annoying. I mean, it's not gonna work, bro. Alright, I can't believe I'm gonna chat GPT this, but I'm gonna chat GPT it. I'm gonna say getting fully random numbers. Time. It's ridiculous. And you would think that it works. Cryptographic libraries in C for random numbers. Open SSL. That's probably a good one, actually. That's actually probably a very good one. Open SSL. Let's see. Let's look into that. Let me share the screen so you guys can follow too. Open SSL. How do you build this in C? I don't really use C very much. I just want to do it. That's kind of annoying. Oh, whoops. Okay. I need to get that anyways. Oh, we're using Windows. Doesn't help. That does not help. Oh my gosh. Yes. Yes. I'm not gonna lie, this just looks like quite a lot. Building up. Dude, that seems like way too much. When this happens, you go to ChatGPT. SSL or any C library for that matter. Yeah, we have that. Install C compiler. I don't know. I think I have one. I have MinGW. We already did that. Pre-compiled binaries. Open SSL. Downloads. Okay. So that's there's our tar whatever file. We need to open this. Is it impossible to open this file? I don't think so. When the installer and note where it installs. Yeah, well, that doesn't. Hang on. I hate this part of coding, bro. This is like the dumb part of coding. No one likes this part. Oh my gosh, what is it? I don't really care about where the binaries go or whatever, bro. Like, honestly, I really don't. Oh, well, it opened something. It opened up tar.gz. Opened it over here. Where's the readme? Readme. Look at this whole project. This is whatever. I don't plan to. I don't really want. Okay, look. I don't really care about right now about like open SSL or any third-party library. I'm only doing this because I want to get a better understanding to how you can even import other libraries in C and use them. C, what? I've never even heard of that. It says, and your C. Walk me through. Well, I already have. Yes, yes, there we go. Dude, why is this so confusing? Dude, no. Oh my gosh, my thing's like tripping right now. Distract. I don't know what's happening. This is getting really, I'm getting really annoyed. I might just like quit and just stick with this. No, it's Windows. Holy moly. What a nightmare. What a nightmare, bro. This is a nightmare. I did not think it was gonna be this hard to install and use a fucking library. How to how to install a library. Let's see. Or Windows. Yes, code. Step by step. My gosh, it's like you gotta do like a bajillion steps. Yes, right here. How do you add another library? Yes, this is it. Dude, my goodness. Do this, bro. This is just pissing me off. You can't put that. Come on, man. This is so annoying. I'm actually getting really annoyed now. I'm getting quite annoyed. Okay, so it says you need to install Perl. Fuck it. We'll install Perl. I know Perl is like a scripting language. I have never used it in my life, but I know it's a pretty decent one. I don't know what you can do with it, but it says here. Okay, just load up Perl. Yes, it's fine. It's ridiculous, bro. Spending all this time just to spending all the time just to install a library, bro. What? This is so annoying. Yeah, I'm back an hour in, not even writing a single line of code because I have to install this open SSL. Did it work? No, it's almost done. Is almost finished. So we need to install NASM to NetWide Assembler. We'll install NASM too. We will install NASM as well. Then what does it want us to do? I see. Install Perl. Make sure they're on the path. Man, nightmare. This is it's giving us bajillion different errors, man. It's not even done yet, bro. What? How many files is this? Did it work? Did it work? I don't know if it worked or not. I installed Perl. But did it work? I have no idea. Oh my gosh. Oh my gosh. Install it. Okay. Okay. Fuck this shit. I will keep it a buck with y'all. Fuck this. I'm going to pivot. Fuck this shit. I don't even fuck it. I don't need RAM numbers right now. Maybe that's God. This is God telling me you don't need RAM numbers. Fuck this. Fuck this. Okay. Fuck it. We're not even gonna account for RAM numbers. We're not even gonna generate any right now because clearly my computer wants to give me a fuck ton of problems when they want to do it. So I'm gonna get my iPad. Oh man, we're just gonna implement, and yeah, we're just gonna implement. Bro, what the fuck? We're only gonna implement our lattices. So let's recall the algorithm, which we have over here. But you guys can't see this, can you? You guys cannot see this. So let's just choose um what? Oh, I can't start with it. That's why I forgot. Um, let's say. Oh wait, am I tripping? Did I instantiate that wrong? I think I'm mildly retarded. Let's say we have three. Let's say we have 24, 30, 12. Okay, so what's the greatest common denominator from that? Okay, I don't know if this is even gonna even compile. I'm not gonna lie. I can't clear the terminal. What the? Am I tripping? Okay, there we go. What? I don't know. I don't really know shit about C, about developing programs in C. I more or less just do this because I'm bored. This is C. It's called the output. Should it work? Will it run? Okay, it ran. Yeah, go. Wait, we can do a test right here. Say first element, first basis vector is all I'm doing here is I'm just trying to test to see if this is even gonna work. That's all we're doing here. Oh, whoops. Same thing. Okay, cool. So this instantiation worked. I'm sorry I had to do that. That was just. Anywho, okay, let's define the Euclidean algorithm. So let's define Euclidean algorithm for finding points. Okay, so what do we need to do? Let's actually first just do the case with two. Then we'll make it recursive once we get that. Okay, so let's just. Dude, it's because they don't have a dot length field, bro. That's why they don't have the length field. Oh my goodness, they don't have a length field. Uh, I think it's because it's treated like an int. Ah, when you pass this through, it treats this like a pointer. This is the exact same as treating it like a pointer, right? Is that what's happening? Oh, man, I'm fucking stupid, bro. Oh my gosh, I'm fucking stupid, man. My gosh. Dude, my dumbass needs to pay more attention in Compart. This is what's happening, bro. It's just taking the size of each int, and so this will be size 16, right? Yeah, size 16. Okay, so the real size is equal to size of. So there we go. Now we should the right output. There we go. Okay, okay, that makes a lot more sense. A lot I was tripping. I was like, it's a pointer, it's pointer. No, no, that's really just, I was being stupid. The integer is 4 bytes. So the size of the array is 8 bytes for two integers. So you really have. Anyways, okay, cool. So let's go ahead and shut the fuck up, Google. I didn't even call you. Okay, Euclidean algorithm. What's the first thing we need to do? We need to have base cases. If so, this is in the case that we're assuming that a is equal to size 2, s equals 2. So we're going to say if a 0, 0, return a 1, same thing as a 1. So two base cases. And then we do recursive case. You don't have to do this like this because we're actually going to do double recursion, but it's still cool to do. On the recursive case, what needs to happen? We need to return Well, let's put it into quotient form. How do we do that? We did what was it called? It was R and B, right? With R being there was yeah, R and B. So let's call R and set it equal to a and we don't want we just all we want. Yeah, round up, round down, doesn't care. And Q is equal to the mod, right? So it's the same thing, but we just include the mod. So recursive case, give the R and Q, and then all you need to do is return Eucalg with R. Oh, it's gonna break it though, isn't it? The array doesn't break because this is why. Because we're gonna be setting this equal to R and this equal to Q. So actually, if we really wanted to save some lines of code, we could have just set a equals 0 equal to. No, we couldn't. We couldn't. It would modify. No, that would be bad. So just set equal to 0 and then just return Eucalg uh, a cool. Let's run it. See what we get. Let's call this the results. Final result. Final result is something results. See? GCC. That's wrong. That is wrong. The thing is how we're passing this through. So it's a reference to 24 and 30. We update everything. So 24 and 30. I see. That's kind of annoying. I think we have to do the greatest one first. That's the caveat. Yeah. Wait, that's wrong. Wait, it should be 6. What? What's going on? What is going on? What in the world is going on? I can't believe I'm doing this, but I'm gonna have to GDB this. GDB. Wow. File. Oh, do I have to do? Oh, is that why? Yeah. Okay. Let's set a breakpoint on. Oh, wait a minute. How do you exit? You can't. Gosh. Man, GDB, you are useless. You are not helping right now. You are not being helpful at all, are you? in the world? Like, kill, die. My goodness. Oh my gosh. This is like a nightmare. Science error is 2, final result is 24. How is that right? How is the final result 24? What's happening here? 24 divided by 30 is 0. Wait, that's wrong. Wait, bro. Hang on. Let's take a look at what the Euclidean algorithm actually is again. Because I think I'm just tripping. Oh my gosh, I knew I was tripping. I'm tripping, bro. Like 270, 192. This is I'm actually kind of retarded. Uh, R is the mod. So it's two. So we'd calculate. Modded. I'm fucking retarded too. Dude, I'm cooked, man. That should just be this. It's our Q that's wrong. Q, because we're not trying to find Q. We don't give a fuck about Q. We only care about B. I found the wrong thing. What is B in this sense? B is the. Oh, what? Wait, the B is just the other guy. B is just. It's even easier than that. And we just need to set a 0. The first value is equal to the second value, and the second value is equal to R. Okay, let's try it now. Perfect. That works. Okay. We can also get rid of this. This shouldn't be there. So now let's generalize to the nth case. So now generalizing to some case. Let's pick one that's kind of hard. So let's just 6 right now. Let's do 16. Now it should be 4. It should be 4. It should still be 4. Okay. So now we can't do this anymore. Because for whatever reason, it doesn't. Well, actually, okay, before we generalize it, let's create it to where if you give it two inputs like this, it won't it won't tweak out. Let's like do that first. Let's do it to where it won't tweak out if you do. Because right now, I'm pretty sure if you run this, it's not going to work simply because It did work. Oh, that's pretty cool. That's pretty cool. It did work. I thought it wouldn't. I thought it had to be in order, but I guess it doesn't. Yeah, that works. Let's give it some more. Actually, let's test out. Let's do 28. So what should this be? It should be 4. That's the least common denominator. The greatest common denominator. It should be 4. Good. Okay, great. Now let's do the end case. Let's choose 6. Let's choose 22. Let's choose 102. 100. Actually, let's do 110. So the result should be 2. So if a equals 0, so it's going to pass in this into here. Okay, so let's make a note and say 1 computation, 2 values. Right, this is what we have. This will give you 2 values. So let's normalize this to give any value given this array. Let's do how are we gonna do this? So let's plan. So if we have an array of A, B, C, D, E, what is the first thing we need to do? We need to calculate GCD AB, GCD with C. Okay. So what's the base case? And then we need to do GCD A, B, C with D, GCD A, B, C, D with E. That's the recursive, I guess, flow of logic. So what is the base case? Let's say if we might need a variable to count, like a counter variable, and just say a current, and I call it like the current index maybe. It's not a bad idea. Yeah, that's not a bad idea, is it? Let's give it a counter index. That might help. Let's call it here. I like to keep my name short when I do recursion. Base case. If we do if counter is less than or equal to uh, S. Only on this case we want to actually run. Actually run. Otherwise, we just don't we want to just stop. So we'll have like a return 0 at the very bottom if it. But I think here we're gonna have to like, play around with this and say like if AC equals to 0. And C plus 1, C plus 1, 0. So those are the, and we're gonna need like a recursive, we're gonna need like a recursive. It's recursion inside recursion, which I think is gonna be kind of tricky. But I do want to try it. I think it's a fun brain teaser. So let's keep this recursive case. I like this recursive case. It's very silly. Obviously, we need to do. I just realized it has to be less than s because if c is equal to the size is 5. Oh, it actually has to be less than s minus 1 now that I think about it. Yeah. Because think about it. If your counter is, let's say the counter's at, say the size is 4. It's 4. That means there's elements 0 through 3, right? We can only access up to element 2 because we're going to look at the third element too. So it has to be less than size minus 1. And size minus 1 will be 3. So it has to be less than 3. It has to be 2. So that's right. Let's do the same thing. Just generalize this to the C plus 1 case. C return. I'm just a little worried because we have to still. I don't know if we can do this actually. Now that I think about it, I don't know if we can just do this. Oh, fuck. What is it? Hang on. Let's think about this for a minute. Because I'm worried that on the recursion case, so the problem if I just put a C plus 1, if I kept the C's in the way they were right now, the problem is if we kept those in there, what'll end up happening is it'll just update those, but it won't return. Oh no, wait, no. I think it works. Wait. Uh, what is the redo button? Whatever. Find out. This might work. But we only want it to return. Ah, I see. That's cool. Let it return that. Don't modify this line yet. This because we still need it to do the computation to get it to these two integers. Once it has those two integers, then we can iterate. So then we can say, go all the way down. It's still telling us 4. Okay, so it's not working yet. So it's 4. No, this is interesting. I think we have to draw this one out. This is tricky. I don't want to chat GPT this one. I would like to actually do this because this is a pretty cool algorithm. And I think it can be done pretty simply. I mean, dude, this is only like what? Maybe like 15 lines of code. The fact that you can implement a very fast solution using recursion to find the greatest common denominator of a set of integers is pretty cool. I think it's pretty cool. Base case. Oh, I think I have an idea what's happening here. I think I have a brief idea as to why it's not working. I think it's because of this line right here. So after we return this value, we need to actually store this. We need to actually store this result. Then we need to also make sure we set AFC equal to res. Okay, let's try this. Fuck. No, it's not working. That line doesn't belong. We just needed to compute this value. So compute this value, whatever. By itself, this actually works. By itself, this works. And this will work, I believe, for two integers. So this should return the right. Yeah, it returns right values. It returns 4. Because it's only checking this. It's only returning that. Let's see what the results were in the first place. Oh, now we should probably do that. Make it easier. Eyes. Hey, that's an important thing. What? So it's 54. What are they on about? I'm kind of retarded. This needs to be below. Sorry, above. There we go. All right, condensates iteration. All right, a right. Okay, so we're just iterating through, and we find 4. Okay, great. So the final result is 4, and let's do this too. We're gonna say helping me see which values of A we're gonna need to set. So let's go ahead and just run this. Wait, what? Whoa, 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 what? Wait, hold on. Whatever reason, that just fucked everything up. I can't even tell you why. What in the world? For some reason, that print statement just fucked everything up. How does this form? Yeah, that's right. I don't understand, bro. Oh my gosh. Oh, I don't understand what's happening with this. For some reason, it doesn't work. Why doesn't this work? This should work. Make AC equal to res, and then instead of returning res, you want to return. Oh, what? Return the algorithm plus one. To be fair, I don't know if you can do this though. To be fair, I don't know if you can just do this. Now that I think about it, I don't think you can. This is like we're trying to do two recursive things in one function. It doesn't really make sense, does it? It doesn't really make sense now that I think about it. We really can't do this. Oh, taking a quick break. Dude, I hate data structures and algorithms. Data structures and algorithms makes me sad. I hate it. Anyways, let's go back to it. So this works. I didn't know it was going to make an unnamed too. I could just literally just call that do it for me. Oh, maybe that may well maybe we could do this. Let me just do it. C equals 0. I think we're gonna get so I think we're close. I think we're very close. All right, forbidden fruit time. Let's see what I'm doing wrong. Say I'm gonna actually ignore a lot of this. Saying this is enough. Is that true? Is this enough? No, that is not right. Like I knew it wasn't right because I'm like, okay, you know what? I might actually just end up. do. There's a way to do this. There's a way to do it. You know what? From scratch. All over it. There is a way to do this. Iterative version 2. It's pretty easy. We're gonna do 3 more. Yeah, we can only do this recursive. We can do just do iterative, and then we can do the recursive step, bigger one, and just keep this one. Just, R equals be another int. Oh no, we just said 0. This will work for just 2 values. So let's run this for 2 values. Cool. Yeah, it works. It's just kind of the first 2 values. So now let's actually, okay. There's a lot of bullshit we're doing. Now let's do this. We'll expand to the recursive case now. So on the recursive case, of course, it's the counter. Only run if the counter is less than 3 do size minus 1. Yeah, let's do size minus 1, that's fine. It's less than turn. Copy the iterative version here. This will compare 2 values. No, but I don't like this. I don't like this formatting, bro. I like my formatting way better. No offense. No offense to the compiler. I like my formatting better. It's easier to see on the eyes. I think it is. Small differences make a big deal, I think. Okay. Now we can just generalize this to this one, C plus one, C plus one, C. What's next? What's next? What's next? Okay. So we have the currency. I believe now we just need to modify the array. So let's modify the array. We do that here. Um, bro, why is it taking so fucking long, dude? Holy shit! I'm so tired, bro. Like I just don't want to do this. I do want to do this. I like. FC is an S minus one. You run the two-part problem. C is less than S minus one. I'm gonna draw it out. I'll draw it out on my iPad. If C is less than. This says C plus turn. Oh, please work. My goodness. Okay. Okay. You know you're cooked when you gotta pull out the original debugger. That's what we're gonna do right here. Screen mirror. Okay. Okay. So what are we doing here? We have a couple of values. We have oh, right? This is what we have. So C less than yes. Uh-huh. while this will do all the we'll get v equals 4 if a of c equals a is 4, and then we have this is probably the part where we're starting to mess up on part where we instantiate. Um, right? And then return, we call it Euc again, right? Hmm. Well, A is, what is A? A is 24, 28, 6. A is 24, 4, and 6 now. But it should still give us 4 and 6. Also, I lied, the size is 3. Wait, but this should give us the right output. It should give us V equals. Wait, we did it right. We did it right for the most part. Between 4 and 6, the greatest common denominator is just 2. That's same. I'm kind of retarded. I know I never actually return anything, do I? Oh, I'm kind of retarded. I never actually return anything. I think we should maybe a return B, maybe. So run this again. No, it's still little. Well, so we have v equals 2. Now we're gonna instantiate 24. Ah, that's clever. the answer now. I think the result is just stored in this call. So we're going to have return a size minus 1. Oh, whoops. That's CC. There we go. We got it. We got it. We got it. We got it. The only caveat is this. We do modify the input array. We do modify it. Is there a way to not modify it? There probably is. But for the time being, that's pretty cool. We got it to work. That's dope. Let's test it out even let's do with 11. We should get no output now. Because there is no greatest common denominator. Good. Yeah, 1. Because 1 is that's trivial because you can't really count 1. Let's do 4 again. Let's do 4. This should give us 4. Ah, cool. Awesome. Okay, will work. The sucky part is it does modify the input array. It does. But I mean, what's the big order of this? This is order. Yeah, the order of this is very, very minimal. Okay, that's cool though. We got it to work. Obviously, sadly, yeah, the order is n log max int. Nope. But yeah, that's the only thing is it does modify the input array. That's the only caveat. We do modify the input array. I'm trying to think of a better way we could do it. Because there is a way to improve this. You can always improve algorithms. How do we not modify it? I'm not sure. I'm not sure there's an easy way to do that. No, but there's always a way to make it better. There's always a way to make it better. I think the way to do it here, I think the way that we can do it, only modify 2 elements. You get 2 elements at a time. You find that and use that with A, maybe. It'll take some experiment around to do. It'll take more space. This is why. The only reason is because um, oh, index I is. Yeah, y'all agree. Y'all about to see this. This is not going to look very nice. Oh shit! I always like keep forgetting. I don't you make files here. GCC testing. Yeah. So we end up like making the whole thing kind of. The whole array is kind of fucked up towards the end. Is there an easy way to fix that? There probably is, but it would take a lot more. It would take a little. It would take more integers for sure. We'd have to use more space. Well, less space, but it'll be more code. Like here, like I think it was something like this. We're gonna be like temp1 equals. Let's see, just store these variables and it'll restore at the very end. All we would have to do. So we'd keep two temporary variables, AC and AC1. I like it better when it looks like that. I don't know. Keep two temp variables. This will modify everything into V. That's the key right there. Is the int V part. That's the catch. Maybe we can do something like this. We'll keep it on the recursive call and something like this maybe. This could work. Just return V. Keep two temp variables. Iterate through. Li. Maybe it would look better if we do it like this. Yeah, readability is it's kind of important, isn't it? So how would we need to how would we restore these two variables to the where they would belong? Well, let's see. We need to so iterative version. This is fine. This is just used to calculate V. This is all V calculation. Once we calculate V, so here now we have V. But we stored in that. V and V is the 2 increment. Well, let's put V in here maybe. Where does V belong? Where does V belong, guys? Where do we put V? Put it in this code. Where could we put it? See this was 1 is not equal to 0. This one is necessary. Ah, it needs to go here, I think. Nice iteration. So we have we just wrote the C plus 1 element is equal to V. Get away with just putting it. You know, like that. -1. If v is -1, just say just tell on the first iteration. No. Oh. Where? Makes sense. All right. Can't think of a better way yet. And I'm not gonna leave here until this is finished. So we got to where it wouldn't break through, but now it's breaking the array. 24 not equal to 0. Alright, so now we calculate the new v. Should be 4. And now we'll pass 4 in the new parameter. Oh, wait a minute. Let's see. Wait. V is 4. 0, and let's try decreasing. So we have here. Let's try going back to the 2 case. Okay, and let's track this out again. So let's say so we have 24. Temp 1 is 24, temp 2 is 28. V is -1, which it is. V is equal to 24. While V is not. Well, it's just skipping this, isn't it? It's just skipping this. Oh, well, it's just skipping this. It's saying is not equal to 0. V is not getting modified. V is not, this needs to be AC. It has to be. That it has to be AC here. This might not even be necessary. Work, but I know it's gonna break the array. But it's gonna work. Never mind. We're just gonna find these most common denominator. It's gonna be equal to 4, right? So I get 4 into V if AC 0. Whole point is we're gonna set V equal to 4. Wait, V should not, V should never be -1, only in the first call, but S minus 1 is 1, and C is 0. Let's see what, let's print out what this is V. This is taking way too long, but I really want this to be good. I doubt I'm never gonna even use this, to be very honest with y'all. So we got V is 4 down here. V is 4 is that all temp again. Oh, wait, what? Wait, what? Wait, now I'm really confused. So we're getting, okay, so we're getting V is 4 both times. We're getting V is 4 both times. Meaning that V is 4, V is 4, C plus 1. So how is that possible? We're updating V, no? This is not the same V that we just passed in. In this case, C is now 1, S is 2, so S minus 1 is 1, and 1 is... So it's going to fail, and it should return B. But clearly when we get there, it doesn't. How, bro? How in the world? Maybe it's again, are we updating B? Another int. I think we're treating it like another int. I don't think it's being updated. I think it's treating it. There we go. Yeah. Holy shit. We're treating it like another int. That's so stupid. What? Why would C let you do that? That's, I mean, to be fair, that's, you know, y'all heard that saying? Like, that's what C does. Okay. Okay, sick. Does it work if we add one more variable? Let's add 4. No. Let's add 2. This should change. This will change the result, or it should change the result. Okay, no, it's still failing. We fail on, but that's really good. We're doing good. We're preserving the array. We're just not getting the right value. Well, only for like the case where it's 2. We get more. For some reason, it just doesn't like it. It doesn't. It throws a fit. Oh, but it does it because of this. This is what's happening. We get b equals 4. The grade is the same. We call plus 1. So we now the array is 28, 28, 24, 28, 2. V is equal to 4. C is equal to 1. The issue is right here. So now is when we can input. We can use a condition if V is -1. If V is not, A is C is equal to V. Okay. Will this work? Not quite. But I know what the problem is. And we're doing C is 1, so this is C. So it really should be doing 4 compared to 2, but it's not. It was before. A of C equals to 0. Whatever, just B should be just 2. Okay, let's see what we're getting for V when we keep doing this. V. This is what we're getting for V. Oh, well, there we go. We got V equals 2, so we got V equals 2 there. Start V. Dude, this is taking way longer than I thought it would take, to be honest with y'all. But this it's good. This is very good. I've spent like an hour and a half on this maybe. Ah, spent very long on this. At least we're implementing a decent I think this is a decent algorithm for Euclidean algorithm. I think this is a decent one. We're not modifying the input array. We're keeping it polynomial time as little close to the input v as possible. I think we're doing a decent job. I mean, yeah, it's not great, but I mean, for what it's worth, it's not bad. I don't think it's bad. If it's bad, then I'm gonna cry because I've been doing this for hours. Well, not an hour. That's been like an hour and a half on this algorithm so far. These lines of code took me quite long to write. This wasn't an easy algorithm to write. Well, it probably is easy for most people. I don't know. It's just harder for me. I don't like. I don't know. I just don't like. I guess this part of like recursion. It's just boring. I think it's not boring. It's just difficult. Time consuming for sure. So C is, let's just run from the start. S is equal to 3. So S minus 1 is equal to 2. V is negative 1 at the start. Okay. No, it says here start V is 2. So we're getting start V is 2. And it'll fail there. It's for some reason, it's on this return. Now start V is 4. Very good. Now we'll run through all this, hit this. Now start V is 2. Ah, right there. Dude, my, my gosh. My 314 teacher or data service teacher would kill me if you saw me coding like this. He would be like, why you always have to do the else in the in the recursion. That's why I was failing. It took me like a minute to see, and I was like, oh, what's happening? It's going to this, but I held back here. It should look at this short circuit and go back here. Are we finished? Do we have a robust algorithm? We wrote this in how many lines? Approximately 20 lines? 30 lines? Approximately 30 lines? And we preserve the lengths of we preserved the lattice vectors and just found the greatest common denominator of these three values. That's very cool. It's very, very cool. Let's run some tests now. Let's test. 972 20. Should be 4. I don't know actually. Maybe it's 4. Yeah, it is 4. Cool. Look at that. And it preserves the values. Dope. Now let's add a 2. You guys should know what will happen. It should be now 2. So it's 2. And it's 2. Great. Last test. Let's put 1. Put a 1 and let's put a -6. Oh man. Cool. Should just be 1. Okay. That's dope. We did it. Let's commit this. Um, let's sync. Yeah, we did good. That's dope. Third lines of code, we've written a Euclidean algorithm that is decently robust, recursive, and most importantly, order and log max. Let's look at the GitHub, see if it's on there. Oh man, we'll take a break right now. I have some work I gotta do for Compark. That'll be my break, per se. Q shield. Dope. Dope. All right, y'all. That'll be it for now. I'm gonna come back on here later. We're not done for today. I have some free time today. I'm gonna finish up some assembly code for my Compark class. Um, other than that, we're gonna